G'day guys, welcome to lecture 2, adding and subtracting vectors. Here are your learning intentions and success criteria. Please complete the knowledge and skills table like we've been practicing. Pause the video while you complete this. Okay, so looking through these, so we can see here through our learning intentions we need to be able to calculate resultant vectors by adding and subtracting, and to succeed at this we've got a couple of things. We were defining distance and displacement, so that gives us our first knowledge that we should be able to define what is distance and what is displacement, and then finally we should be able to define what is a vector, in this case a resultant vector specifically. In terms of skills though, well, these two calculate verbs, these are our skills because you've got to actually be able to do something for that, and so we need to be able to add vectors, we need to be able to subtract vectors. Okay, now we're going to work, to begin this topic, we're going to work with the idea of length because it's the thing we're most familiar with. And I can ask you a couple of things. So for example, let's say that we're in a classroom, there's my school, let's do K for K block. I can ask you, how far is it to your house? I can ask you, how tall are you? I can ask you how far you walk today, so from your home over to K block, around the school, and then going back home. These are all examples of lengths. Now, let's look at a really simple scenario, and I want you to think about your definition of a vector. Remember, a vector requires both magnitude and direction. So here is a desk. So it might be the desk at the front of my lab. And here I am at the start, and my desk is 2 meters by 1 meter, and if I walk this way, then here, and then I walk back this way, the question I could ask you would be, how far have I travelled? How far? And let's say how far travelled. Or I could ask how far away. Okay, so how far away am I from where I started? I want you to pause the video, I want you to think about how you could answer these two questions. Okay, great. Now, some of you might look at this and go, no, they're the same thing. You're asking me the same question here, but they really aren't, and this is one of the things you need to discover about your education, is that as you go higher, specific language is very important, and your understanding of language will get more complex as you learn more things. So the first question here, how far have I travelled, this is asking us about distance, because all it cares about is the size something is. If I tell you that I ran 2 kilometers today, and another person says, I ran 3 kilometers away, objectively we can say, yes, that person has gone a further distance than I have. But if I say, I ran 2 kilometers west from where I started, and they say, I ran 3 kilometers but I ended up back where I started from, okay, well, he's got a further distance, but I've gone a further displacement. I've ended up being further away from where I started compared to this other person. And so this question, second question here, how far away am I? This is asking about displacement. Alright. Now, we have here a couple of definitions, and sorry, I thought I would have printed them, but I didn't. So the first is distance. Now, distance, things we need to know about, it is a scalar. It is measured in the metre, which is given the symbol m for metre. So for example, if you walk 1200 metres to school, and then 800 metres to the shop, and finally 500 metres back from the shop home, you've gone a total distance of 2500 metres if you add those up. Now note, I didn't put a direction there, it's just how long the path was. And when we add scalars together, we just add numbers together. It's the same you've been dealing with your entire life. Now the second question though is asking about displacement. Okay, now this is a vector quantity, so we need to give it a direction. It has the same units though, so displacement is a vector, but it is also measured in meters, so it has the same symbol m for meters for our units. Now both of these have their own symbols as well, but we'll see those when we start adding. Actually, let's add them now. So distance is normally given the symbol d, displacement though is given the symbol s, sometimes it's given the symbol x. Now these are some things that you probably want to have noted down somewhere in your book as an easy reference. I would recommend you look up the definitions for distance and displacement as well. Okay, so let's go back to this original question. Instead of asking how far have I travelled, I'm going to ask what is my distance, or what is my distance travelled. And for the second one, I'm going to ask what is my displacement. Now, before these two questions, how far have I travelled and how far away, they could be a little bit confusing because of just the vagity of language. But this is physics. We don't have vagity of language. We must have very specific instructions. So you will see things like this. What is my distance? Okay, what is my displacement? If you get something like how far has a person travelled, that's when you start running into assumptions and you need to be careful about your communication. So I'm going to give you a couple of seconds. I'll pause the video please and work out. In this situation here, I've walked around my desk. What is my distance? How far have I travelled? What is my distance? And then finally, what is my displacement from where I originally started? Alright, now, if we have a look at this, we can see the desk was 2 meters long, then 1 meter, then 2 meters. There's certainly an argument to say, oh, but what about the distance from you being away from the table because you weren't right on the edge of the table? That's just adding extra complexity, and it's not really going to get you any extra points. And when we look at exam questions, if this was worth 2 points, and you were asked to calculate distance and calculate displacement, showing that sort of extra fancy working out as saying, oh no, it's 1.5 meters on that side, or 1.5 meters there, 1.5 meters there, so it's 2 meters because he's got to walk around the table. That wouldn't really give you any extra points. It's just going to take you longer on your exam. So don't try to overcomplicate it. These questions are not designed to be trick questions. So if I go on 2 meters down, 1 meter, 2 meters across, 2 plus 1 plus 2, so D equals 5 meters. In terms of displacement though, well, I've gone 2 meters west, or 2 meters to the left, 2 meters to the right. So let's write that 2 meters left plus 2 meters right equals 0 meters. And I've gone plus 1 meter down equals 1 meter down. So my displacement, we'll give that the symbol S, was 1 meter down from where I started on the page. Okay, so remember though, because this was a vector, displacement's a vector, I need to give it a direction. So it's very important to understand the difference between distance and displacement in the physical world, because most of the rest of this unit is going to just rely on those definitions. Everything else that we look at just comes out of, well, how do we look at terms of distance and displacement? So do be very, very careful with that and make sure that you are really wrapping your head around that. So if you need to, pause it, go back to the start of this bit and re-watch it again. Okay. So when we add vectors, sometimes you'll be asked to find the resultant vector. And if we look at this word, write this up the top here so it's out of the way, resultant, we can see it's made of two parts, result and ant. Let's ignore the ant. Let's just focus on the root word there, resultant. Result means the answer or the end point. So when the textbook is asking you to find the resultant vector, all it's asking you is a fancy way of saying, what do you get when you add all these other vectors up? Alright, so when we add vectors, there's going to be one of two cases. Either the two vectors we are adding point in the same direction, or they point in different directions. So for example, I say I walk 1 meter west. Let's draw me. I go 1 meter west. And then I go another 2 meters west. Well, what's my resultant vector? I'll do this in a different colour. So my red pen's a little bit stuck. There we go. What's my resultant vector? We'll call that x for now. Well, we can see there, if I add them together, it's going to be 3 metres west. And so if we were to do this on a board, we would go 1 metre west plus 2 metres west equals 3 metres west. And we're done. Okay. I could use the sign conventions. Okay, so where I've said 1 metre west equals -1 metres, because remember we defined in our last lecture that west is negative. 2 metres west equals -2 metres. So -1 metre plus -2 metres equals -3 metres, which equals 3 metres west. We can see it's exactly the same. Now this sort of extra fancy working out here is not really something that's worthwhile doing, and on exams it won't buy you any extra marks, but it does help at the start, just to help with clarifying your thinking so that it becomes just second nature. So case 1, really easy. If it's going together, you're not going to have a problem. But what if we're going to look at case 2, where they're in different directions? Okay, so case 1, same direction. Okay, so now let's look at case 2. Case 2, different direction. So, here's an example for us. Here's me. I start off by going 1 metre west, but then I go 2 metres east. So what is my resultant vector? What is my final displacement? Now here, I didn't really emphasize it much in terms of explanation, but I started at the start and went to the end. So here I'm going to start at the start and go to the end. The fact that I originally went left doesn't matter. So x here equals, I don't know. What do you think it'll be? I mean, it looks easy, and it is easy when we look at it pictorially. When we look at it with a picture like this, we can kind of see, oh yeah, if I go a metre to one side, then 2 metres to the other side, it's just the same as if I just went 1 metre to that second side there. So let's do the working. We know it's going to be 1 metre east, but let's do the working. So 1 metre west plus 2 metres east equals, well, here's a problem. If we just think about our basic algebra that you've been doing since grade 7, over here, well, we had some west and some other west, well, we can just add the west together. But here we've got a west and an east. We don't have a way of linking those. We know what it is, but we can't show that it is. So let's do some proper working similar to what we did over here. So 1 metre west equals -1 metre. 2 metres east equals plus 2 metres. Well, now minus 1 metre plus 2 metres equals plus 1 metre, which equals 1 metre east. So now we've got, sorry, let's slide down a little bit. Now we've got the answer that we thought we should get. Okay, and so this is why, as I said in lecture 1, it's very important to define your directions as positive or negative so that you can work with these vectors. So vector addition in one line is pretty straightforward, but you have to be careful with your positives and negatives. Okay, and eventually down the track we'll do vector addition with 2-dimensional vectors, but we don't have to worry about that at this point. Alright, let's have a look at subtracting vectors. When we are talking about subtraction, what we are really asking is, what is the change, or what is the difference between two numbers? If I write something like 5 minus 3, well, we know the answer is 2. What we found here is that the difference between these two numbers is equal to 2. So subtraction equals difference, or change. And that's a good thing to really wrap your head around. Now, change is such a common thing in physics that we give it the symbol delta. So change equals delta, okay? Because we don't want to write change of displacement, change of velocity, change of energy, change of momentum over and over and over. So we've got a shorthand for it. So when I say write delta T, remember T means, capital T means temperature, we looked at that in lecture 1. What I'm really asking is, well, what is the temperature? Well, if I want to find what is the change in temperature? If I want to find out what the change of temperature is, I need to know two things. What did we start with? What did we end with? And we're going to use the words initial and final. So change in temperature would be equal to temperature final, F for final, minus temperature initial. F equals final, I equals initial, and we can define that as start and end. Now, I'd like you to look at the worked example on page 280, and that will show you how to do with picture forms of vectors. And we'll cover why we do arrow changes in direction in class, but it does cover why it happens in the textbook, so have a read of that. And now, it's not a technique you necessarily need for exams, but it is useful for some questions later in the program. So, let's say have a look at an example like this. If we have a point we call 0, and I am initially at a point 5 meters from 0, and I walk up to the point 8. That's a wonky looking 8. Okay, I walk up to the point 8 meters away. So this is 5 meters, this is 8 meters. Well, I might be asked, well, what is the change of my displacement? Okay, well, we just saw that change means final minus initial. So change equals temperature, not temperature, let's read that again, equals displacement final minus displacement initial. Well, my final is where I ended up, and I ended up 8 meters away. 8 minus 5 equals 3. Okay, I moved positive 3 meters away from my start. If I went the other way, so I went here and went back to there, well then my delta S would be 5 minus 8 equals minus 3 meters, or, you know, if this is 3 meters east, that would be 3 meters west. And again, we're using the same conventions that we've been seeing before. So to work out the change in something, you just need to know start minus finish. Now this is why sometimes it's really useful to say, let's start B at 0. Because if I'd move this back, so instead of having this at my 0, let's make this 0 and this 3, because we know that's how far away that is. Instead of having 0 all the way back here, well now our difference would just be equal to 3 minus 0, which equals 3, if we're going that way. Or 0 minus 3 equals negative 3 if we were going that way. Or if we were to define our start point here at 0 and this point here at minus 3. See how we're always getting the same size answer? Okay, it didn't actually matter what positions we used, because we care about the difference. Okay, and whether I say that 0 is over here, or 0 is here, or 0 is here, it actually doesn't matter. Okay. Now, subtracting vectors, I'm going to leave a little bit more for in class, because this one is something that there's a couple of different ways to do it. They're a little bit more involved, and it's important to talk through it and make sure we understand it. So it's not the best thing to do through a video. Okay, but have a look at the textbook, have an attempt of the questions, because it will be fairly straightforward, and you'll get your head wrapped around it reasonably quickly. Okay, so for our learning summary, we've done 3 things today. We've learnt what is the difference between distance and displacement. Right? We've learnt how to add vectors together in 1D. And we've learnt how to subtract, or how to find the change between 2 vectors in 1D as well. Alright. For your entrance slip to class, I would please like you to complete questions 1 to 4 in chapter 10.2. Check your learning PDF and copy your answers for 1 to 4 into the 1.2 space on eLearn. Alright, thanks very much guys, I'll see you in class.